we're now going to be looking at a strategy that only works in situations where we have equations where we've got a fraction on the left-hand side equal to a fraction on the right-hand side. So something like this, A on B equals C on D. Something where we've got a fraction equal to a fraction. It doesn't work if we had something like this. So if we had A on B plus C equals D on E, that means it wouldn't be able to work. If we had something like A on B equals C on D minus E, also doesn't allow it to work. It can only be a situation where a fraction equals a fraction. It's a pretty cool technique. In this situation here, imagine that we just had A on B and we were trying to get A all by itself. What would we do to both sides to get A all by itself and move that B? We would multiply both sides by B. Now, let's look at the other side. Imagine that we had this, not worrying about what's on the other side. And imagine we were trying to get C all by itself. What would we do? Well, we would multiply both sides by D. So what that means is, as a shortcut, we can actually do a wonderful thing here. We can multiply B over to this side of the equation, and we can visualize it as multiplying A over to this side of the equation, meaning that we're going to get this as our next line. AD, representing A times D, equals BC, representing B times C. This is sometimes called cross multiplication, but again, this only works when we've got a fraction equal to a fraction. So let's actually have a go at solving some equations that involve this. First off, in the first example we have here, do we have a fraction equals a fraction? We sure do. Fraction on this side equals each other. So we are going to be using that multiplication technique. So, in order to do that, when you've got more than one term in our numerator or denominator, we need to pop brackets around that. That's really important because when we multiply this 2 over here, that 2 needs to influence everything on the top of that numerator here. And brackets are our best friends to be able to achieve that. So, this can be represented by 2, and then in brackets, x plus 6. That 2 is multiplying not just with the x, but also with the 6. To achieve that, we use brackets. Now we pop in our equal sign. Now this 4 is going to multiply with everything on the other denominator here. So we're going to have 4, and then in brackets, 3x plus 1. So the critical thing is here, we multiplied the denominator of one side over to the other side to interact with the numerator there. And we must include brackets to be able to solve this. Now there are multiple ways you could go about solving this now. One way that will always work is just expanding out these bracket friends. So to do that, 2 times x gives us 2x, 2 times positive 6 gives us plus 12. Got that equal sign in there. 4 times 3x will give us 12x. 4 times positive 1 will be 4. I really like to identify the smallest pronumeral value. So we've got 2x is our smallest one here. So we'll do the opposite to both sides. We'll take 2x away. So on the left-hand side, that gives us 12. On the right-hand side, we're going to have 12x minus 2x. We're going to have 10x plus 4. Okay, let's use the strategy of swapping around the sides. So I've done nothing here other than swap around my left and right hand sides. It makes it a little bit easier to visualize. So now we'll take 4 away from both sides. 10x is going to equal 12 minus 4 is going to be 8. And then divide both sides by 10. X is going to be 8 over 10. Now pause. We've got a fraction here. Is that as simple as it could be? No, we could actually simplify it further. X is going to be 4/5 or 4 over 5. Okay, let's look at another example here. We're going to use that fraction equals fraction technique again. So because we've got 2x over 5 equals x over 2, fraction equals fraction, that will work fine. This 5 is going to multiply up here, and this 2 is going to multiply up here. We don't need brackets around things for this question because we've only got a single term in all the numerators and all the denominators. So 2x times 2, represented by that purple arrow, is going to be 4x. And 5 times x, represented by the yellow arrow, is going to be 5x. Ooh, this is an interesting one. Now, I've noticed we've got 4x equals 5x. Well, let's use the strategy we mentioned before. Find the smallest value with pronumeral attached to it. It's going to be 4x. So we're going to take 4x away from both sides. And this is going to have an interesting result. If we have 4x take away 4x, we're going to have 0 left on the left-hand side. And then 5x take away 4x, well, we're going to have 1x left, which we can just write as x. Let's flip that around because we like to have our pronumeral on the left-hand side. This is actually a really interesting result, x equals 0. And I guess that makes sense. If we have 4 times a number, and it's got to be equal to 5 times that same number, the only number that fulfills that is going to be 0. There's no other number where 4 times a number equals 5 times that same number. X equals 0 is a perfectly acceptable answer to an equation here. So sometimes that happens. Don't worry if it does. It's perfectly normal. Let's look at the next one now. Now this one doesn't currently look like fraction equals fraction, and we could solve this without using this technique, but just to practice this technique, how could we make this into a fraction equals fraction situation? Hopefully you recognize we have a whole number here, 2, and any whole number can be written over 1. So what does that involve then? This isn't necessarily the way I'd go about solving this question, it's just some extra practice of looking at fraction equals fraction scenarios. Now, we've got that x plus 3 here, so we'll just pop some brackets around that. So what's going to go on here? We're going to have 4 times 2, and the other situation will be 1 times this x plus 3. So how could I represent that? I could show it as 1, and then in brackets x plus 3, equals 4 times 2, so that's going to be 8. Now, if we expand out 1 times that bracket, we're just going to have x plus 3 equals 8. And then we'll subtract 3, x equals 5. So this one is very similar to if we just started with x plus 3 over 4 equals 2. And because we have a denominator of 4 multiplying by 4, x plus 3 equals 8, minus 3, x equals 5. So although we've approached it from slightly different techniques here, I think the second technique is more efficient, but it is nice to know that using fraction equals fraction is a very legitimate way of solving these equations. So it's perfectly fine to use that technique here. Oh, now we've got an exciting one coming up next. In this question here, let me just zoom in so we can focus on it. Oh, that's huge now. We have fraction equals fraction. And we already have some brackets going on here, so that's really interesting. Let's do what we were talking about before. We're going to multiply this 3 over here, and we'll multiply this 2 over here. So, if we look at the orange one first, so we're going to look at that 2 times, and then 4 in brackets x plus 1. Well, we're going to do the 2 times 4 first. So 2 times 4 will give us 8, and then in brackets x plus 1. So all we did there to get that 8, it was this 2 times this 4, still out the front of the bracket, it's still about to multiply with the x plus 1. Now let's do the one in pink, or the 3 times 3 in brackets, 2x minus 1. 3 times 3 is going to give us 9, and then 2x minus 1. Now you might have decided to multiply out the brackets on those numerators first, so your working out might look a little bit different to mine, but so long as you're very careful with your equation work, you'll get the same answer. Okay, so let's pop that outside of the bracket. So 8 times x will be 8x, plus 8 times 1 will be 8. Then we'll do this little buddy, 9 times 2x and 9 times negative 1. So 9 times 2x is going to be 18x, 9 times negative 1 minus 9. Okay, we've found ourselves in a situation where we've got x's on both sides. That's perfectly fine. My preferred technique is finding the smallest thing with a pronumeral attached, and in this case, that's 8x. So we're going to take 8x away from both sides. Doing the opposite of positive 8x is minus 8x. What does that leave us with? On the left-hand side, we'll just have 8 remaining. And on the right-hand side, we're going to have 18x minus 8x, which will be 10x. And that negative 9 is still hanging out. I like to flip this around now. And then solve as normal. Add 9 to both sides. 10x is going to be 8 plus 9, which is 17. Then divide by 10. X is going to be 17 over 10. Do 17 and 10 have a common factor? No, they don't. And remember, I really like improper fractions, so you can leave that. You could write it as a mixed number as a decimal, but I don't really need that. Okay, this one looks a little bit different from the others because I notice we have x's or just pronumerals in the denominators here. So let's just pause and check. Do we have a fraction equals fraction situation? Yep, we certainly do. So that means we can use the fraction equals fraction technique. Now, whenever we have something that has a numerator or a denominator, I should say, that has more than one term within it, we pop brackets around it. So let's pop those brackets in there. Now we're going to use that technique where we're going to multiply. So now we're going to multiply this x plus 1 up with this 2. And we're going to multiply this x plus 4 up with this 3. So what does that become? Well, if we do 3 times that x plus 4, the 3 stays there, and x plus 4 goes in brackets to multiply with the 3. Remember, if we didn't have brackets there, that 3 would only attach itself to the x, but the 4 also needs to be involved. Now, if we do the second lot here, x plus 1 times that 2, well, traditionally we write the 2 out the front of the brackets, and then the thing in brackets. So rather than writing x plus 1 and then 2, let's write 2 and then in brackets x plus 1. Okay, so let's go ahead and expand this out. Now that we've expanded it out, I like to find the smallest value with a pronumeral attached. Now we solve as normal. So the only extra thing to know here is when we have a fraction equals fraction, we can use this technique where we cross multiply. Then we had brackets on both sides, so the technique I find really useful here is just to expand out those brackets. Then we had an x on both sides, but that's okay, we've dealt with that before. We managed to then get x on a single side by finding the smallest value with an x attached and doing the opposite. And then we solved as normal. Let's look at the last example. Alrighty, warning. Although this might at first look like a fraction equals fraction situation, this plus 7 is stopping us from using that technique because we've got something that's not within that fraction on the left-hand side. But what we could do is we could actually make it part of that fraction so that we could use this technique. So let's actually give that a go. Now, if we have plus 7, we know that that's a whole number and we can write whole numbers over 1. So what we're going to do, let's write down the right-hand side because that is perfectly all within a single fraction there and we don't have to do anything to adjust it. We're just going to be thinking about this left-hand side until we eventually end up with some sort of fraction, a single fraction on that left-hand side. So I've done rectangle over sort of an ovally shape. So if I did that, let's just focus in on this. So we'll ignore this for a moment and just zoom in here. We've got 7x minus 1 over 2, and we've got 7 over 1. Now, let's think back to when we did fractions earlier on. If we want to add two fractions together, or subtract a fraction from another, we want a lowest common denominator. And in this case, looking at the 2 and the 1, the lowest common denominator is going to be 2. To achieve that, let's multiply the second fraction times 2 over 2. So what does that give us? Well, on the left-hand side, we now can draw a big old vinculum with the 2. At the front, we had this 7x plus 1. Minus 1. There we go. Good to check our work. And then we've got plus 7 times 2. So that's going to be plus 14. Now remember, whenever we find ourselves in a situation where we have some like terms going on, we've got a -1 plus 14 here. Let's clean that up before we do any more. So 7x plus 13, -1 plus 14 is 13, over 2 equals 3x minus 25 over 4. So crisis averted. We now have a fraction equals fraction situation. So now is frac equals frac. I can't be bothered writing fraction equals fraction. So this is a more advanced technique, but if you break it down and think carefully about the steps that we've involved here, all we've tried to do is get a fraction equals fraction situation. That meant, on the left-hand side, we just had to join together these two separate bits to form a single fraction. Now we're going to solve it like we've been solving all the other ones. We're going to put brackets around things that have more than one term. This will multiply up here, and this will multiply up here. That becomes 4, and then in brackets, 7x plus 13 equals 2, and then in brackets, 3x minus 25. Now we're going to go ahead and solve this. You might solve it in a slightly different way to me. For example, you might divide both sides by 2. That's perfectly okay. But I'm going to go ahead and expand both brackets, deal with the fact that we have x's on both sides, and then get to a point where we've solved it. And when I say solve it, it means we've got the pronumeral on the left-hand side and just a number on the right-hand side. So as a reminder, with this style of question, we always wanted a situation where we had fraction equal to a fraction. Then we were able to solve this by doing the numerator of one fraction times the denominator of the other and set those both equal to each other. We cannot use this technique if we don't have a simple fraction equals fraction situation, although, as we saw in part F here, we can actually manipulate this to result in a fraction equals fraction situation, meaning we can use this technique. How exciting! We're at a point in maths where we can actually manipulate equations to make them into slightly different looking things to solve them using particular techniques. I think that's pretty cool. Okay, good luck with your questions. Let me know if you have any queries.